Hello all. I'm going to try to demonstrate something that's kind of tricky, and it's in the process of my experimenting with Ingress controllers and Kubernetes, but I'm going to demo bringing up an unencrypted website up in Kubernetes via the Ingress controller and then installing a TLS certificate from Let's Encrypt. So long story short, and this is not a tutorial or anything like that, an Ingress controller in Kubernetes allows you to avoid the situation in AWS or other cloud providers where you may end up having a load balancer per service, if you will. Right now, if you deploy a bunch of services to Kubernetes, you would need to, without the Ingress controller, you would need to actually expose these individual services via a port, kind of like a node port type of a thing, or even a load balancer in most particular. What that basically means is each one of your services would have to have a load balancer fronting it, and that can get a little bit expensive. So with the Ingress controller, you end up having one and only one load balancer in your cluster, and you can use host and path-based routing within your Ingress controller to forward those requests on over through your Ingress controller to your clusters. In the case of secure certificates, the Ingress controller will be SSL terminated right there instead of your load balancer. That you can also do it at your load balancer as well and forward that traffic on over to your Ingress controller. But anyways, that's kind of the long and short of it, of an Ingress controller in Kubernetes. You have to install that separately, and I'll just kind of quickly go through that here. I have an EC2 instance within AWS, and I installed a Kubernetes cluster using COPS, for example. And I won't really get into COPS or what you would need to do to install it on AWS because that's kind of outside the scope of this particular demo. But there's plenty of documentation out there on how you can get a Kubernetes cluster up and running within AWS using COPS. But one of the things I will do, though, is install the additional Ingress controller within AWS, which will also have a load balancer fronted. Excuse me. So when I go to my load balancers, now I want you to know there's this API Fleetman. So I finished another course on Udemy, which is a really good one, and I'll do another video on that, where that gentleman walks you through on how to create a load balancer, and you can SSL terminate right at the load balancer level. But it's a very good microservices course where he deploys it to AWS. And so I kind of left my COPS configuration pretty much the same where I'm using those cluster names, but this particular demo is really got nothing to do with the Fleetman application. Yeah, I just kind of left the name the same. So what I'm going to do is I'm right here, just so you can see, I'm going to install the Ingress controller, which you have to install in addition to your Kubernetes cluster. So there's a couple of prerequisites. Well, not a couple, but there is a prerequisite that we need to do. And I'm just going to go right here and apply it, basically. And so now we actually have our Ingress controller namespace created. And there you can see we've got our Ingress Nginx. So you can have different proxies, reverse proxies, and all that kind of stuff specified as your Ingress controller. We're using the Ingress Nginx because that's one of the well-established ones in the community, and it happens to also be the default one used for Minikube. But basically, that's a Nginx allows for serving as a reverse proxy, and which basically forwards your requests on over to another endpoint. So I've run that proxy, or I'm sorry, I've run that prerequisite, and I'm going to go to the AWS link. Now, depending on what other environments you're getting this to run in, whether it's Azure or Minikube or Docker desktop or whatever, you're going to want to use those. But here, I'm just going to go ahead to the AWS one and copy these two applies here, which basically set up your Ingress controller, and they're also going to create an app load balancer, which is going to sit in front of your controller on Kubernetes. So if I paste this in here, basically, I've got this created. And if we take a look, as you can see, we only had one load balancer before. This, what I just pasted in right here is going to spin off another load balancer right here, and it's using an environment variable that we pass in. But the idea is this particular load balancer is going to sit in front of your, shall we say, your Ingress controller instance, and we're going to go ahead and, you know, kind of let this finish and spin up. So like I said, this is a pretty difficult, this will be a slightly difficult demo for me to kind of walk through and explain. And I apologize if I don't actually explain some of the things in great detail, but you can go to this particular website right here to install, after you set up your cluster, to install your Ingress controller. And I'm going to actually show how to get a certificate installed. But before I do that, I did want to mention this is actually assuming, too, for this particular example, that you have your own domain name, which I do. And so I have a hosted zone inside of Route 53, which I bought on AWS. You don't have to do that yourself. But basically, we're going to have to create we're going to actually have to create an A record for each of our supported domains that we want. And I'm going to go ahead and create a record set. And we will call this www.tbkosick.com because that's my domain. And I'm going to create an alias right here. And when I select here, as you can see, I'm going to select the load balancer that is going to be used basically to pass requests on over to our Ingress controller. So when we ran this original command right here that you're looking at right here, this actually went ahead and spun up and created that load balancer. So all we're doing right here now is forwarding requests from www.tbkosick.com over into this particular load balancer, and we'll do it as an A record. So I just created that, and we'll just go ahead and create another one using the naked domain, which is tbkosick.com, and do the same thing as our alias. Make sure that we select the right one. And so now we have that set up properly. Now the next thing I want to do is just basically install a real simple little web app that says Hello World. So I just randomly went out there on the Docker Hub and found this CRC check Hello World, which basically you know, that gives responses on port 8000. So, and we basically created you can see I got many other examples out here, but I'm going to go to this Ingress Cert folder because that's where I'm at right now. And I just basically created a deployment for the Hello World application right there. So as you can see, the image itself is what I just showed you. And the idea behind there is it's going to create a deployment and a service. And the service is going to forward all the requests that are coming in from port 80 on over to port 8000 in the container, which is what's specified right here. So if I apply this, okay, so now we should have a service and a deployment for our Hello World. So actually we do. So we've got our Hello World service, and we also have our deployment. So now if everything goes okay, and I try to visit that site, as you can see, it's like Hello World right there. We get this connection is not private, but if I go and I say advanced to it, And oh, let's see right here. Actually, I want to reload the site. Bear with me 1 second. Okay, because I had some caching issues, and I apologize. I had to run a new incognito window because still getting some cache results from a previous experiment. So when I, excuse me, try to visit this particular site, we get the connection is not private, and we proceed to the site right here, and we have a not found. All right, so one of the things I did forget to do is was install the Ingress host rules, which I thought I had installed, so I apologize. So basically, this host rules allows for path and rules-based forwarding. So in this case, we've got, I'm sorry, host-based and path-based forwarding. In this case, we've got kind of like host-based, but basically any request coming into tvcosic.com is going to get forwarded on over to our Hello World service. And if we support TLS, which I'll show in a bit, it's it's going to go ahead and get our certificates out of this Kubernetes secret here. So let's go ahead and install this. So we're going to say kubectl apply -f ingress host rules. So we've got that created. And as you can see, we've got our host rules right there. So I was installing Opera here just for, let me just see if we can get this going on this particular demo. All right, so let's see, I'm trying to bring up, let's see here, HTTP, not HTTPS. Keeps wanting to forward us to HTTPS here, which is fine because we've got our TLS thing defined inside of our host rules. So let's see what we've got here. Let's go right here. All right, this was kind of a pain, and I apologize for the deviance. I actually had to delete my HSTS policies because what happens basically is because of the caching, I had visited the site before in previous, shall we say, experiments. So it had remembered the fact that I had visited these particular protected sites that I had certificates on, and then I went ahead and deleted them and reattached them and all that. So I actually had to go and clear my HSTS settings, which is what I did right here in Chrome. It's kind of a pain, but so so now I tried to visit the tvcosic site again, and this time, let's see what we've got here. That's the wrong window. This time I got the proceed to, and here's our hello world. So I really apologize for that. The first time you run this, you won't get that problem, but once you install a certificate, if you will, and then delete it and do the whole process all over again, you're probably going to run into the HSTS issue, which is a nice security feature, but basically behind the scenes, it's automatically forwarding your HTTP requests over to HTTPS, which is what you want 99% of the time, but not when you're trying to demo this, like what I was trying to do here. So once again, I really apologize for that. If this happens to you when you're trying to run these experiments, just remember that you need to go ahead and try to disable HSTS from your browser. And then you can go through the exercise right here. And so this worked for me. Anyways, what you can see right now is we're bringing up our Hello World Docker application, which basically is the CCRC check thing that I was telling you about. And it's not secure. So what we're going to do, but anyways, you know that this is actually working through the Ingress controller. So we're going to tvcosic.com, which is forwarding the request on over to our load balancer. And the reason why this is blank is because in order to clear my HSTS settings, I had to restart Chrome. And so now when I restarted Chrome, I got to probably relog back in AWS, and which is what I did there, just doing another refresh here. So now we're finally good to go. So basically, when we visited this particular site, tvcosic.com, it went through this particular load balancer, which went through the Ingress Controller. And let's take a look at that right here. And using these rules, it went ahead and forwarded that request on over to the Hello World service. And that Hello World service forwarded it on to port 8000, which is what this documentation says right here, where it goes over to port 8000, and it ends up displaying this Hello World. Okay, so now the next step. So now we're basically not secure. We actually have a fake certificate by our Ingress controller, and we need to install a real certificate in there so that we can get a valid padlock on there, which looks happy. Okay, so let's go ahead and fix this not secure problem. So the next set of steps that we want to do is actually go through this installing this extra add-on for Kubernetes, which is our Cert Manager. And Cert Manager is an extra, shall we say, tool. It's an extra object, whatever you want to call it, that will make your life a lot easier as far as installing certificates. And you can set up your expiration policies, and it'll attempt to, basically manually install your certificates for you in certain intervals and save you a lot of time. So what we need to do here is, I just wanted to set up some environment variables. I'm going to follow some of these instructions here. So I'm going to go ahead and create a namespace for the certificate manager to reside in. So we'll say kubectl create namespace cert manager, and then I'm going to basically disable the let's see here, disable the validation on the certificate manager so that we can provision certificates for its validating webhook. So that just basically, I'm following this particular step right here. And again, you can read up on this to actually see more in details about it. But like it says here, it creates a chicken and egg problem where the certificate manager requires the webhook in order to create the resources, and the webhook requires a cert manager in order to run. So I won't actually offer a real detailed explanation on that. I'm just kind of going through the steps right here. And then so the next step right here is to actually install the certificate manager itself. And I created an environment variable which basically contains that repo repository for the cert manager. So basically, if I say repo, that's kind of what it's set right out here, just a little convenience kind of a thingy. And let's paste this thing right here. Got the command, so we're going to apply that. So now we're actually installing our certificate manager. And now what we want to actually do is create the objects that represent the certificate manager controller. So we'll do the same thing right here. I'm just pasting some commands that I had from my previous experiment. So as you can see, there's quite a bit that's involved with installing the certificate manager. Now what we want to do is we're going to want to say kubectl get po-n cert manager. And as you can see, we've got our webhook. Let's see, actually we got one of them created and creating. We've got our certificate manager running. So let's just go ahead and see what we've got here. So now we've got our webhook running. So it looks like we're all set to go ahead and run here. Now let me go ahead and make sure that this is clean. Okay, so we have no secrets. So when I attempt to create or get the certificate from Let's Encrypt, it's going to go ahead and store the certificate itself inside of a secret. So because I was running previous experiments, I wanted to make sure that those had been cleaned, if you will. So getting back to this again, and I totally apologize for the kind of the disjointed thing that's going on right here. I did want to say that, here's my rules again, Ingress host rules for host-based routing. And you can also, let's see what we got going on right here. Made sure that I had my host name set up right here inside of the rules. And it's going to forward the request on over to hello world. And the secret right here, which I have is TB Cosic com TLS here, the secret name. I'll show you how that gets wired. So if we take a look at Let's Encrypt prod. Now, this is not really a tutorial for Let's Encrypt, but Let's Encrypt is allows you to get free SSL certificates that last 90 days, so you don't actually have to pay for a certificate authority here, and these are 100% valid and all. And that's a whole topic and learning unto itself. And I have another video out there, and I'm sure there's a lot of good resources out there on Let's Encrypt. But basically, when you're testing this, you can actually hit their staging server for Let's Encrypt. But I know that I've already tested this before, so we're just going to go straight and get the production certificates. But the staging one basically gets you fake certificates so that you can make sure that your website is actually coming up and all that. And again, if you go through the process of learning Let's Encrypt, you're going to see everything's hunky-dory there. But right here, I'm going to go straight into the production one. And, and we want to take a look at the certificate file itself. I'm just kind of winging it. That's why I sound very disjointed here, so I apologize. But here I am going to create a Kubernetes type of a certificate. And basically, I'm going to rename it or give it the name of what my domain is. The dots become dashes here. You give it a common name for your spec. And then basically, this particular certificate is going to do an HTTP challenge via the NGINX class on over to let'sencrypt.com. And here's our reference or issuer. So I just noticed something. I got to change my issuer to production because I was using staging here. So we'll go ahead and change that to production. Now where that comes into play is if we take a look at the Let's Encrypt.prod. As you can see, we're creating a kind which is an issuer. So, and then we give it a name of production. So that's kind of how we're making the link there. So what I'm going to do is go back to my certificate. I know I'm kind of jumping all over the place, but we've actually linked our certificate object to our production issuer reference. And here's where we actually give a secret. So this is where once we get our valid certificate, so it's going to do this HTTP 1.0 challenge, and ultimately during this whole handshaking process, Let's Encrypt is going to go ahead and give us a certificate that we can use, and Kubernetes is going to go ahead and install that in a secret, which currently does not exist. So let's go ahead and create our issuer. So we're going to say kubectl apply-f, and we're going to say Let's Encrypt prod. So let's do get PO. Okay, so let's do a get all. And let's see, that looks fine there too. I want to say kubectl get namespaces. Let's take a look at our Cert Manager namespace. So we're going to say kubectl get all minus n. Okay, so we've got our webhooks running right there. If we take a look at our, just kind of just taking a look here. Taking a look at our Ingress controller namespace, make sure that we got things up and running there too. Now what we want to do is we want to say kubectl describe issuer, and we're going to say acme.let's encrypt, and we're going to say production. And as you can see, what we've got here is we've got a type of ready. You can see that we've went ahead and registered our account right here. So to the Acme Let's Encrypt production right here. So we've got some links set up right there. Now the last thing we want to do is actually apply for the certificate. So again, that's this one right here where we're actually going to go out and get the certificate itself. And you'll see where we get a secret that's created right there. So again, if I say kubectl get secrets, all right, let's go right here and say kubectl apply-f. All right, so we've created this particular, so let's say kubectl. I think we could say get cert. Not quite ready yet. Okay, I went ahead and cleared my screen, and let's go ahead and do the same thing. Okay, this time you can see we went from a ready false to a ready true. So if we say kubectl, I think we could say describe cert www.tbcosic-com. As you can see, it went through the HTTP challenge. We went ahead and got our certificate from Let's Encrypt. As you can see, we went through these particular steps down here. Certificate issued successfully. And again, if we say kubectl get secrets, you can see we've got our particular secret that's been created right here. So if I say kubectl describe secret, lo and behold, our TLS certificate and key have been installed inside of here. Now, as a result of this, we've got our valid certificate from let'sencrypt.org. And hopefully, if all goes well with this particular thing, if I reset the site or refresh the site, this should turn into a secure icon. But before I do that, I just wanted to mention one last thing again as a refresher. It's basically the host rules file that says if you're coming in through HTTPS, through our Ingress controller, then use this as your secret. So this is how we make the link from HTTPS to where we actually get our certificate, which is installed in the Kubernetes cluster in that secret that I just showed you. So this name right here has to match the name of the secret that we created. So having said all that, if I go ahead and refresh this, before I refresh that, I wanted you to see that we've got our fake certificate right here. Actually, I noticed I had a little glitch inside of here. That wasn't working. My secret name wasn't 100% matching the secret name that I had here. So I've got TBCosic. Let me make sure here. TLS. Okay, let me redo these. So I apologize. Okay. And we're going to clean some things up here. So what I'm going to say is I'm going to delete kubectl, delete secret. You know, in a way, it's kind of good that you're seeing these errors because this is probably the way things work out there in production land. So delete secret, www.tkosic.com. Oh, when I applied it, it probably would help if I typed in the right name. Okay, so this looks a little bit better, so let's describe the secret. The reason why this wasn't working before is because it was still using the old certificate, and the reason by that is when I clicked on it, I could see that it was still using the fake certificate, which I had from the staging server. So you're kind of getting to see what happens when you use staging there too. But if I say kubectl describe secret, tkosic-com TLS. Okay, we've got our certificate right here. So hopefully this time, because I applied these two files, hopefully this time we'll have better luck. Let me go right here, tvcosic.com. See what we've got going on here. It's still, okay, I'm going to try to have to clear my cache. Okay, I just closed down my Chrome browser, and we'll see what happens in Opera. And okay, so because I didn't have anything in the cache, it actually found the certificate from Let's Encrypt right here. But again, I apologize. I'm having some caching issues with Chrome. So I just went ahead and re-cleared my cache in Chrome. And so let's go ahead and visit this site again, tvcosic.com. There we go. And so now that error went away, and as you can see, we've got a valid certificate, which is coming from Let's Encrypt Authority. And I know this was a very disjointed demo and that things weren't always working as smooth as they should. But that's, you know, I didn't really do any video editing here. And in a way, it's kind of good that you got to see some of the problems I encountered when I had a few of these experiments already working in the past. So you will encounter some caching issues. And one of the good things that I'm glad happened with one of the errors was the HSTS issue, where I actually had to go ahead and clear that, because you'll probably run into that same issue when you're trying to run these experiments here. But what did we manage to do right here? So we managed to create an Ingress controller that fronted a website in Kubernetes. Now, in my case, I actually have it up in the AWS cloud. And, you know, so which actually had to go ahead and install the certificate manager as well for Kubernetes, because outside of the box, it doesn't exist. But again, you can do, you know, a bunch of resource on certificate manager and what it does for you and things of that nature. But it makes your life easier as far as when it goes out and needs to automate the automatic issuance and renewals of your certificates. And so it applies your certificates right in your Kubernetes cluster inside of secrets. So let's again, we got our host rules. And as you can see, here's my domain, which I have in Route 53. And all requests to this domain get forwarded to the Ingress controller's load balancer. And that happens, and I'll show you again the magic on there. But once it gets to that load balancer, from the load balancer itself, it forwards in all those requests to the Hello World service on port 80. And basically that Hello World service on port 80 right here, which I have specified here, re-forwards that request on over to port 8000. And that's just simply because this particular container, this web app container that I was using for the Hello World, goes ahead and forwards everything to port 8000. And once you're there, because we're using HTTPS in that case, it sees HTTPS and it says, oh, then we are definitely TLS terminating, SSL terminating that connection, basically turning your encrypted data into unencrypted data using this particular certificate, which we define inside a certificate YAML, but it's basically going to forward that request on over to the service unencrypted, which makes it to its pod unencrypted. And then back out, it's an encrypted form again. But in order for TLS to work, it needs a certificate. And again, it uses that secret name. And again, that secret name is what we created right here when we went ahead and used the Let's Encrypt production issuer. And I know I'm just kind of like really going all over the place here, but that issuer is yet another object in Kubernetes that we created. See this kind issuer, and we just gave it a name of production. And this is the key right here. And it uses the HTTP challenge. So you can read up about the HTTP challenge and how Let's Encrypt uses that to handshake with your site to prove that your domain, in my case, tvkosick.com, is owned by me. So it sends a bunch of challenges and data back and forth. And at the end, when it passes, you ultimately get a certificate. And once we get that certificate's stored in this particular Kubernetes secret. And again, I know I'm being redundant here, but I just wanted to kind of drive this point home. If you say kubectl get secret, there's that secret that we created. And we can say kubectl describe secret. And we can say tvkosick-com-tls. Oh, wait a second here. I thought you could say describe secret. Did I just type something in wrong? Yes, I did. I've been doing that a lot. So actually, I was missing the TB. kubectl describe secret. And here's our certificate, basically installed with our private key. So all of that information is kind of wired around and exchanged and passed into your Ingress controller. And that is ultimately why we end up with a scenario like this, where we have a valid certificate from Let's Encrypt being issued to my domain. And that's why we are able to visit our particular website here in a basically secure and legal manner. And as you can see inside of Opera, everything looks happy there too. And if I try to visit the same site inside of Firefox, that works too. So again, I apologize for the disjointed thing, but I felt that that was probably a much more realistic example. You know, because like when you go to online sites, basically that have tutorials and all that, they always give you the happiest of paths. But I did wanted you to know that I was kind of running into some stumps and hurdles through this particular thing, but I learned a bit along the way. So hopefully this helps set you in the right direction on what you need to do. I didn't attempt inside of AWS to show you how to install COPS or whatever. That's just, you know, if you're using AWS, that's just it was kind of outside of the scope of this particular, shall we say, demo. But if you were curious, you could go through, you know, the sequence of installing COPS, basically, and you can go to this particular site and go through these examples based on, you know, what your environment is and stuff like that. It is a little bit tricky, but once you have it set up properly, then you can go ahead and manage your Kubernetes clusters within AWS. You do want to be a little bit careful, though, because with COPS, you do want to make sure that, you know, especially when you're running examples, like here I'm using Fleetman, Like I said, it was from a previous Udemy course where we were doing SSL termination at the load balancer level. But keep in mind when you install Ingress, when you install the whole Ingress deployment, you will get a load balancer created out of the box. So by that Ingress utility. But the good news, though, is you won't have to have a load balancer per service. So you can have many services in the back, basically sitting in front of all of your pods, but you got one load balancer, which is redirecting everything over to it, particularly with path-based routing in that case. But I hope this kind of helps. And, it's not the easiest thing in the world, but at least you're aware of the components that you'll need. Like in AWS, you probably want to have COPS installed. You're going to want to have a domain name installed. You're going to want to basically have, link up your domain name to your load balancer for your Ingress controller. That's going to forward your request. So that's kind of what I've done right here with the A records. And then you're going to also want to make sure that you install the Cert manager within Kubernetes and follow the instructions on how to get your certificates issued. And then you're also going to want to set your rules, basically your path rules and stuff like that, which is, so I've got my container application running, you got your certificate YAML, you've got your host rules, and then you'll probably want to play around with your staging just to test out your certificate process. And once your staging succeeds, then you'll actually want to go for the real deal and go straight to your prod, which will, let's encrypt prod YAML, which will go ahead and install the certificate itself inside of a secret. So anyways, thanks for watching me kind of go through this disjointed demo, but I hope it helps at least inspire you and get you to do some exploring investigation on your own and how you can actually get TLS certificate installed within your Ingress controller within Kubernetes so that you can basically start TLS terminating your services. So again, thanks for watching, and I hope you have a great one. Bye-bye.